VLSos here. This is a video lesson on the product rule for differentiation. Let's work with the equation y is equal to 3x squared times the sine of x. And hopefully we can immediately see that this function is more complicated than a single polynomial term. We have the product of 3x squared and sine of x. We can think of these two parts of this product as functions in themselves and label them f and g. We'd think of the structure of this equation as the function f times the function g. The pieces we can list. If we have said that f is equal to 3x squared, we can immediately take the derivative of that piece, which is 6x, using the power rule. If we've labeled the second function in this product sine of x, we can immediately take the derivative. The derivative of sine of x is cosine x. Taking the derivative of this equation is not as simple as the product of the derivative of these two terms. It's more complicated than that. We have a property that can be proven by other means. The derivative of the product of two functions, in this case f and g, is equal to the derivative of the first function times the second plus the first function times the derivative of the second. This is the structure of the derivative of the product of functions. And if we have the pieces that go into this structure, we can substitute them to find the derivative of our equation. In this case, the derivative of y will be equal to the derivative of the first function times the second plus the first function times the derivative of the second. It's often possible to simplify or factor once following the derivative of a property like this. But if you are asked to just find the derivative, I would recommend not doing algebra further. Stop once you've taken the derivative. If this is a part of a contextual problem or further work, it may be helpful to factor, combine like terms, or simplify if possible. Let's have another example. I'm going to define the z function to be sine squared of x. And if we are to find the derivative of z, then it is not as simple as the cosine squared of x, because this is a product of sine of x and sine of x. We can think of sine squared x as the product of two sine of x's. We can use the product rule on this, but in this case, f and g are the same function sine of x. And so their derivatives are going to be equal as well. And we are reminded from the first problem that the derivative of sine is cosine. So the derivative of z, thinking of z as a product, is going to be the derivative of the first function times the second plus the first function times the derivative of the second. And because it doesn't matter the order in which we multiply, we can think of these two terms as the same term and simplify this to be 2 sine x cosine x. And indeed, what we've done is we have proven what we're going to consider now to be a property, that the derivative with respect to x of sine squared x is equal to 2 sine x cosine x. This is something that we often commit to memory so that whenever we need to take the derivative of sine squared x, we can convert it right away rather than continue to go through this process.